So this is the circuit we're about to solve. This is a mixed circuit. So we've got some of the resistors in series with our source, which is 45 volts. And then we have a couple resistors over here that are in parallel with each other. Now the only things we're given in this circuit are the source voltage, which is 45 volts, and we're also given the resistances, and that's it. So everything else we're going to have to find ourselves. And so what I'm going to do to start is I'm just going to label some of the currents. It's conventional current. Here's the positive terminal of my battery and the negative one. So here's one of the currents. I'm going to call this IT since it's the current through the battery. Once it hits this junction right here, some of it's going to go through resistor 2, which I'll call I2, and some is going to go through resistor 3, which I'll call I3. Once they join back up at this node, it'll be IT again, heading towards the battery. Now, because I don't know any of the currents and I don't know any of the voltages across the resistors, I'm probably going to have to find an equivalent resistance. So I'm going to have to boil this whole circuit down into the source voltage, the current going through the source, and one equivalent resistance. So I'm going to do this in a couple of steps, and I'm going to show all my steps. The first thing I'm going to do is I'm going to combine these two parallel resistors. So just below, I'm going to draw the same circuit. I'm not going to draw all the lines on the battery, with R1, which is the same. And beside R1, I'm just going to draw an equivalent resistance, which I'll now label R23. And this one's R4, and this is still VT. So what I've just done is I found an equivalent resistance. And since this is a parallel organization of resistors, if I want to find an equivalent resistance, I use this formula. So 1 over R23 is equal to 1 over 20 plus 1 over 80. And so to solve this equation, I'm just going to plug this into my calculator, and then I'm going to take the inverse of that sum. And that should give me R23 is equal to 16 ohms. So now what I can do is I can boil this circuit into one final equivalent circuit. So I'm going to draw this one more time, same battery, except I'm going to add up all of the resistances, same total current, and I'm going to call this R1 to 4. So that's my equivalent resistance. Actually, no, I'll call that RT because that's my equivalent resistance. So in order to find this resistance, because I'm just adding up resistors in series, I'm going to be adding up R1 plus R23 plus R4. So my equivalent resistance will just be, what was R1? 10 plus 16 plus 4. So my equivalent resistance is just going to be 30 ohms. Nice and straightforward. Now that I have the equivalent resistance, I can figure out IT. IT is the voltage, 45 volts, divided by the equivalent resistance. So 45 divided by 30, and I get 1.5 amps. Now that I know IT, I can go back and look at my original circuit. Now I know IT, so I know the current that's flowing through R1, and I also know R1. Knowing those two things means I can find the voltage drop across R1 really easily. When I look back to R4, I know that the current flowing through R4 is also IT. Since I know the current through R4 and I know the value of resistance 4, I can figure the voltage drop across R4. So let's go ahead and do that. So I'll go back to, I'll change color. I'll go back to R1. If I go back to R1, I know that the voltage drop across R1 is equal to the current through it times its resistance, which is 1.5 times, it was 10. So that's a voltage drop of 15 volts. If I go back and look at R4, the voltage drop across R4 is the current through it times its resistance. So that's 1.5 amps times 4 ohms, which is 6 volts. So now I know the voltage drop across R1, I know the voltage drop across R4, I know the voltage gain at my source. I know enough information to figure out the voltage drop across these two resistors. There's a couple ways you can go about this, solving this part of the circuit, all of which are equivalent. What I'm going to do is I'm going to use Kirchhoff's voltage rule. So I'm going to use this loop, and I'm going to call it A. And I'm going to say, okay, the voltage gain through the battery is equal to the voltage drop across resistor 1 plus the voltage drop across this load plus the voltage drop across resistor 4. So if I look at loop A, using Kirchhoff's voltage law, I know that the voltage gain due to the battery is equal to the voltage drop from 1 plus the voltage drop across resistor 2 plus, 2, 3 together, since they're in parallel, plus the voltage drop across resistor 4. I know most of these things. This is 45 equals 15 plus the voltage drop across 2, 3 plus 6 volts. So the voltage drop across resistor 2 and 3, both of them, is 24 volts. So just to be clear, that's the voltage drop across resistor 2 and the voltage drop across resistor 3, since they're in parallel. Now, again, you can go ahead and solve for the currents through these directly, which we can now do. So, if we go back up to R2, I know the voltage drop is 24 volts. Oopsie. I know the voltage drop is 24 volts. I know that the resistance is 20 ohms, so I can figure out the current. So back to R2. I know that I want the current, I2, which is V2 divided by R2. V2, we just said, was 24, divided by R2, which was 20. So that gives me a current of 1.2 amps. Finally, I'll do exactly the same thing through resistor 3. So the current going through resistor 3 is the voltage drop across it divided by its resistance. So 24 divided by, back to the top, 80 ohms. That's going to be a much smaller current. That ends up being 0.3 amps. If we wanted to just double check, using Kirchhoff's current law, the current I2 plus the current I3 should add to the total current going through the battery. And we can just double check. 1.2 plus 0.3 gives us 1.5 amps, which is what we found above. So that's pretty good. Again, you can go about solving this circuit several different ways, but all the ways you'll end up with the same final results, and as long as you're showing your steps, you'll get full marks on a question like that.